Hi, I'm Liz Nedden. Let's have a look at applications of the Poisson distribution. So a couple of reminders about some key rules. So one of them is about this and. So as soon as we talk about and in probability, that means to multiply. So it means A has happened and B has happened, so they both must happen. And so and in probability means to multiply. Or in probability means to add. So that means it could be an A or an B or in both. So it could be in either of those things. So that's when we're going to add it together. So or is add and is times. So let's look at this example. So we've got a factory making rope with a mean number of faults of 0.3 per 100 metres. So the mean, where's my pencil gone? There we go. My mean is equal to 0.3 faults. Now remember with Poisson, the mean is equal to the rate. So our rate is 0.3 faults per 100 metres. Okay, so I want to find the probability that neither of two separate lengths will have any faults. So I need to have, I've got rope number 1 and I've got rope number 2. So I've got two ropes. Notice I'm saying and I need to find the probability that it doesn't have any faults. And I want to find that for both pieces of rope. So that's my first step, is to find the probability of no rope, and then I'm going to combine them together to find the probability of no rope for two pieces of rope. Sorry, no faults for two pieces of rope. So we want to find the probability of no faults. So let's go to our calculator. And so let me just remind you of this. So we go into the stats mode and under distributions. So I'm going to press F5. I don't see the Poisson there. I need to go across. So F6 and there's my Poisson. So F1. And in this case I want it equal to 0. So I want PPD. So I'm going to do that. Now the X value that I've got, I want to find the probability of 0 faults. And my mean rate is 0.3 faults per 100 metres. So that's going to give me a probability of 0.7408. To 4 decimal places. Okay, so that's the initial part, finding the probability of no faults. Now I need to deal with the fact that I've got two separate pieces of rope and the probability that both pieces of rope have no faults. So I want the probability of two ropes having this criteria is the probability of 0.7408. And notice, remember, I did an and back there, so it's times 0.7408 again. And when I multiply that, and you could write that, by the way, as 0.7408 squared, that would be fine as well. And that will give you an answer of 0.5488 to 4 decimal places. So that's the probability of two ropes having no faults. Let's have a look at a second example. So this has got the same mean rate. So we've got our mean rate of 0.3 faults per 100 metres. And I want to know the probability that one length of rope has one or two faults. So notice that word or in there. So one or two. So I want to know one or two. So that means I need to add. So I want to find the probability of one fault, and I want to add to that the probability of two faults. So let's go to our calculator, and I'm still in the Poisson mode, so that's all good. So I'm going to go and find the probability of one fault, and that is 0.2222. And I'm going to add to that the probability of two faults. So let's go up and do two faults here. And that gives me 0.3333. So I'm going to add those together because all means to add. And that will give me Oh, hang on, did I write that number down right? 0.03, sorry, I've forgotten a decimal in there. 0.03. So that will give me 0.2555 to 4 decimal places. So and is to multiply or is to add. Another thing that we need to be aware of is that the rate is proportional. This is one of the underlying assumptions of it. So when we talk about a rate being proportional, if I know that my rate of faults is 0.3 faults per 100 metres, then if I have 200 metres of rope, then each 100 metre section would have the same rate. So if I wanted a 200 metre piece of rope, then that would have an overall rate of 0.6 per 200 metres. Okay, if I wanted to extend it and do it over 300, a rate per 300 metres, then I would do my 0.3 plus my 0.3 plus my 0.3. That would give me a rate of 0.9 faults per 300 metres. So this is what it means to be a proportional rate, is that we can extend the rate out and assume that it is proportional. So let's use that idea for this question here. So we've got another factory has a rope with a mean number of faults of 0.4 per 100 metres. So the mean, which is also the rate, is 0.4 faults per 100 metres. Calculate the probability that a 200 metre length will have no faults. Okay, so I want the probability of no faults, but I want it for a 200 metre length. So that's what I need to change first. So I need to change and get my rate per 200 metres. And so I'm going to double. So 0.4 times 2 is 0.8 faults per 200 metres. Now I'm going to go and calculate that probability. So I want the probability of 0 faults with a rate of 0.8 per 200 metres, and that gives a probability of 0.4493 to 4 decimal places. Okay, one last question. So now we've still got the same climbing rope with a rate of 0.4 per 200 metres. The factory produces a 200 metre length and a 50 metre length, and we want to find the probability that they both have exactly one fault each. Okay, so I'm going to separate these into two parts. I'm going to first of all deal with having a rate per 200 metres. So I want to know what's the number of faults per 200 metres. And I want to know what is the rate of faults per 50 metres. So I need to deal with each of those separately. So my original is a rate per 100 metres. So that's a rate of 0.4 per 200 metres. So for 200 metres, I'm going to double. So that's going to be 0.8 faults per 200. For 50 metres, I need a half that. So it's going to be 0.2 faults per 50 metres. Now I want to find the probability of getting exactly one fault in both of these situations. So let's get our calculator here, and we'll do our 0.8 first because it happens to be on the screen there from the last question, and I want the probability of exactly one. So put 1 in there, and that gives me a probability of 0.3595. 0.3595. Now we're going to repeat that process with a rate of 0.2 faults. So I'm going to change my rate here to 0.2 faults, and that gives me a probability of 0.1637. So now I need to combine that together. So I've found the individual probabilities of getting exactly one fault. Now I will need to find the probability that rope 1 has that condition and rope 2 has its condition. And so and in probability means times. So I'm going to take that value there of 0.3595 times 0.1637, and that multiplies to 0.0589 to 4 decimal places. Thanks very much for watching.